Assalamualaikum and selamat sejahtera. My name is Muhammad Ashraf Aqil bin Saisfaizal, and today I will present about my final year project 1, which is a finite element analysis on foldable child restraint system (CRS). Okay, for the project summary, child restraint system or CRS generally known among the people in this world to provide protection for the young children during traveling. Okay, the CRS is designed to reduce the pressures the child's body experiences during a collision or tremble caused from the road by absorbing the impact energy and release it over a large area. Other than that, it also equipped with some features like side impact protection and energy absorbing padding. Okay, in this project, I will design the suitable CRS using CATIA software, and will do some analysis by using finite element analysis method to evaluate the performance of the CRS. Okay, next, I will start with the introduction. Okay, in Malaysia, 965 children die annually on average between 2007 and 2009 because of traffic accidents. 43.8% of road traffic collision victims younger than age 4 were driving in privately owned vehicles such as cars at the time of the accident. Okay, for the USA, there were 1,038 youngsters involved in car accidents. It showed that 797 of them were passengers and 215 who were non-occupants, which are from pedestrians, cyclists and others. Meanwhile, in Japan, Japanese car passengers aged from 0 years old to 9 years old had 8,573 injuries and 13 fatalities in traffic accidents in 2019. Okay, this statistic show that most of the passenger does not implement the CRS while they traveling with their family. Okay, as we can see, after applying the CRS, we can see that the CRS can reduce the risk of death by 70% for babies and 47% to 54% for children aged 1 to 4 years old. It also, the injury rates among the children aged from 0 to 4 years old are predicted to drop by 50% and 80% according to World Health Organization (WHO). Okay, in this content, I will share about the two types of position that usually the CRS was applied. Okay, there are two positions that the CRS can apply, which are the forward-facing position on the left side and the rearward-facing position on the right side. Okay, in this slide, I will share about the difference between a forward-facing position and rearward-facing position. Okay, first for the forward-facing position, when the accident occur, the force of the impact is absorbed by the child's body, which can increase the risk of injury. This position also not suitable for the children who are under the age of 3 years old, because typically they have soft bodies that are more prone to harm even from minor impacts. Okay, the next one for the rear facing position, considered the safest approach for young children compared to forward facing restraint, since they provide the most protection in the case of a collision. When a crash occurs, the force of the collision is absorbed by the back of the child's seat, which can decreasing the risk of harm to the child's head, neck and spine. Okay, this position can be conclude that suitable for the children who are under 3 years old. Okay, next I will share about the problem statement and the objectives. Okay, in this project, there are some problems that we need to define. Uh, Most of the CRS that existed were not user friendly is one of the issues. Because some cars have limited trunk space that make challenging for the user to fit the CRS inside when they are not in use. Okay, in this case, we I I use uh, 2022 Produa Alza 1.5x as a reference to design a suitable dimensions of CRS, because the Produa Alza has a small trunk that estimate about 498 liters when the third row sits down. Okay, then the next problem is the CRS will use some space and make other passengers uncomfortable because of the limited space provided, especially for those who has a big family with only one car. Okay, so for the objective is for the objective are to determine the CRS design requirement by referring the capacity of the trunk of Produa Alza, to design the appropriate CRS using the determined design parameters, and the final one is to analyze the performance of the CRS using a CATIA software by using FEA analysis method. Okay, next I will go to the scope and limitation of the project. Okay, in this project I will more focus on the children who are under 3 years old. As I mentioned before, the suitable CRS position is a rearward facing position, which need to evaluate the mechanism performance and safety in various scenario and situation. Other than that, I will emphasize the CRS suitability for usage in Produa Alza and its ability to keep it when not used. I will also concentrate about the back seat performance and safety when a crash impact occurs. Okay, for the analysis, I will uh, make analysis about the internal forces and stresses within a cross-sectional element under various loading condition. And the second one, I will determine the displacement and the deformation. Okay, for the limitation of the project is standard height and weight, standard age, height and weight restriction defined when a child is too tall or heavy to use the seat, because if the children who are exceed this weight and height, these are not sufficiently protected by the rearward facing positions and might require a change to a different child safety seat. And the other one for the limitation is the rearward facing position for the CRS may not be compatible for all the vehicle model, because they are meant to be used in a certain kind of vehicle. Okay, next I will go to the methodology. Okay, there are totally 4 phase that I used to 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 do in this project. Okay, for the phase 1 is I will gather and collect some pieces of information by researching some related articles. I also use PDS technique in this phase to know about the features and the requirements of the CRS that has been existed right now. Okay, I also do some hand sketches to get a raw picture of the CRS. Okay, in phase 2, the CRS can be designed using a CATIA software by referring to the design parameters in phase 1, such as a suitable dimensions and features of the CRS. Okay, In this phase also, I will apply the efficient material after finishing the design of CRS. In phase 3, after complete the preliminary design of the CRS, I will go I will perform FEA using a CATIA software. By doing finite element analysis, the result can show to determine the performance of the safe CSR for the young children. Okay, for the last phase is the result of the FEA should be analyzed when it is completed to determine any parts that could use improvement and confirm that the child restraint system complies with all applicable safety requirements. If the results are insufficient, a preliminary design must modify and fix it. Okay, next I will share the preliminary result that I have obtained. Okay, as we can see, this is the final preliminary frame design of the CRS after completely designed by using a CATIA software. The dimension of the CRS for the length is 250 plus minus 20 millimeter, and the height of the CRS is 285 plus minus 20 millimeter, and the width of the CRS is 185 plus minus 20 millimeter. Okay, I also apply the polypropylene for the material. Okay, how I design this is, first I will draw the L shape that can see through the L shape, and then I will pad it about 250 millimeter for the length of the CRS, and then I will draw a side impact protection for the back seat and the base seat for the left and right side. Okay, then I also include the 4 hole at the CRS to reduce the weight of the CRS. Okay, next I will consider a accident scenario to calculate the force impact to apply in the CRS for the analysis. Okay, first, the mass of the Pradua Alza is about 1145 kilogram. The velocity of the car is about 80 km per hour, and the distance of collision is about 140 meter, and the weight of the infant is 15 kilogram, which is equal to 147.15 Newton. So I will insert all the information in the formula. Then I will get the total force impact, which is 2018.99 Newton, and need to subtract with the weight of the infant, which is 147.115 Newton, due to the opposite direction of force of the infant and the force impact. So the total force impact is 1871.85 Newton. Okay, after the total force impact have been obtained, then I will insert the total force impact in the finite element analysis and get some result. Okay, first, at the left side, the figure shows the deformation of the CRS after incident. As we can see here, the CRS will slightly move to the left because of the force impact, which is in yellow arrow. Okay, next figure shows that von Mistress of the CRS. As we can see here, the highest pressure that received on the CRS is 3.13 megapascal, which is in the red region. That we can see on the CRS is more on the left side at the back seat. So we consider that uh, there there is no high pressure at the middle of the back seat or the top back seat that will occur a bad injury for the head and spine infant. Okay, the last one is the displacement of the CRS after incident. Okay, as we can see here, the highest displacement occur 1.19 millimeter, which is in the red region due to the force impact. Okay, as we can see here, there are no displacement occur at the base seat because I consider the base seat not moved because the base seat is attached with the car seat by using a latch system. So the displacement just occur at the back seat, which the highest displacement occur on the top of the back seat. Okay, finally this is my Gantt chart, and what I can say is very useful for planning and scheduling my projects. It also helps to assess how long a project should take to determine the resources needed and plan the order in which will complete the task. Uh, it also a very helpful method to manage the dependencies between tasks. Okay, that's all from me. Thank you.